The next topic that we have to discuss in polynomials is the remainder theorem. Now this remainder theorem, these three lines will scare you if you don't know the basics of division of two polynomials. Okay, so first let's learn how to divide two polynomials together. And for that, a quick revision of basic division. Dividend is equal to divisor into quotient plus remainder. This is a basic, third, fourth class grade mathematics that we know. So if 12 is divided by 4, 4 is the divisor, 12 is the dividend, and 4 times 3, so 3 is the quotient, goes 12, and you get 0 as a remainder. So if you put 12 is equal to 4 times 3 plus 0, you get 12 is equal to 12. Okay. 4 divided by 7, so 4 is the divisor, 7 is the dividend, 4 times 1 is 4, and then 3. So 1 is the quotient, 3 is a remainder. So dividend 7 is equal to 4 multiplied by 1 plus 3 will give you 7 is equal to 7. That's the basic mathematics that we should know. Okay. Now, when we talk about polynomials, let's take px, where px will be the dividend. Okay. And gx will be the divisor. Now, the dividend px, its degree will always be either greater than the degree of gx or it will be equal to the degree of gx. Okay, either greater than or equal to the degree of gx. Next, gx cannot be a zero polynomial. Gx cannot be a zero polynomial, because we know that if we divide anything by 0, that's undefined. Now, qx will be your quotient and rx will be your remainder. The remainder rx can be 0, it can be a zero polynomial, because as we saw here, your remainder is 0 in this case. So when we are dealing the polynomials, there if you get the 0 as a remainder, we call it a zero polynomial. Right? And if we don't get a remainder, we don't get 0, then we say that it's a non-zero polynomial. So Rx, your remainder can be a zero polynomial, or degree of Rx can be less than the degree of Gx. Right? Its degree will be either less than, not even equal to, will be less than, or it will be a zero polynomial. Like in this case, this 3 is actually less than 4. This 3 is less than 4. So similarly, by that analogy, you can relate it to that the degree of Rx will be less than Gx. Now, this formula of dividend is equal to divisor into quotient plus remainder is true here also. Dividend px is equal to divisor into quotient plus remainder. Okay, now let's take this first example of division of two polynomials. So divide px by gx, where px is equal to x plus 3x squared minus 1 and gx is equal to 1 plus x. The first thing that you have to do is first arrange these terms. Like this is x, this is 3x squared, this is minus 1. This is the term which has the exponent of 2. The power of x is having exponent of 2. So this is px is 3x squared plus x, that is in the decreasing order, minus 1, and gx will be, this is 1 plus x. So x 1 means what? 1 multiplied by x raised to power of 0. So this is x raised to power of 1, here it is x raised to power of 0. That's why x plus 1 in the decreasing order of the coefficient of this variable. Okay, now write this as x plus 1, and let's take this like this. Here it is 3x squared plus x and minus 1. Okay, now this first term, pay attention to this first term. This is 3x squared. This is 3x squared, and pay attention to this first term in this divisor. This is x and 3x squared. Okay, what can we do? By what we should multiply to x, so by x, so that we get x squared? Simply multiply this by x. So x times x will make you x squared. And if you want 3 here, so 3x multiplied by x will be 3x squared. Another way is take this first term, that is 3x squared, and divide with this first term of divisor, that is x. So you will get 3x. And same thing is here, right? So this is the first term of the quotient. Okay. So you get 3x. Now 3x multiplied by x is 3x squared. And then 3x multiplied by plus 1 is 3x. You multiply this first term of the quotient with this second term of the divisor as well. Now the basic concept of division, that we do subtraction, so minus and minus. From here you get minus 2x and then you have minus 1. Okay, now this minus 2x minus 1 will be the new dividend, right? Now, and you have to divide this by x plus 1. That's basic concept of division. Here you have minus 2x and here you have x. So minus 2x divided by x will give you minus 2. So the second term of your quotient will be minus 2, right? Minus 2 here. So minus 2 multiplied by x is minus 2x, and minus 2 multiplied by plus 1 is minus 2. Okay, now the basic concept of division says that you have to perform subtraction. So here you have minus sign, this becomes plus. Here you have minus sign, this becomes plus. From here you get 1, right? So this is your remainder, in this case is 1. Now we know that 1 is what? It's actually a constant polynomial. Is actually a constant polynomial. Okay. And if it is a constant polynomial, and basically it's a non-zero constant polynomial, because we know that 0 is also a constant polynomial, but that's a special kind of constant polynomial. All the other constant polynomials are non-zero constant polynomials. Okay, this is 1. What will be the degree of this one? Degree will be 0, because we know that the degree of a constant polynomial is always 0. Sorry, the degree will be 0, not 1. So degree in this case will be 0. Okay, that's why we said here that degree of Rx will be less than Gx. In this case, the degree of Gx, that is the divisor, is what? 1. And in this case, the degree is 0. That's why the degree of Rx is less than Gx. Okay, now this is your remainder. Now if you have to write this in the form of Px is equal to Gx into Qx plus Rx, you'll write this is Px is x plus 3x squared minus 1, and this is equal to what's Gx? Gx is x plus 1. What's Qx? Qx is 3x minus 2. What's remainder? That is 1. Okay, so this is your representation in the form of dividend is equal to divisor into quotient plus remainder. Okay, the next thing, your Gx here, that is a divisor, is x plus 1. Okay, so your Gx is x plus 1. Now what will be the 0 of this polynomial? We know that the 0 of the polynomial means that if you put that value of x here, the 0, then you will get this whole polynomial should become 0. Now in order to calculate that, what we do is Gx is equal to x plus 1 is equal to 0. So from here you get x plus 1 is equal to 0. From here you get x is equal to minus 1. X is equal to minus 1. So x is equal to minus 1 is the 0 of this polynomial Gx, that is divisor. What does that mean? 0 means if you put this at the place of x, if you put minus 1, so you get minus 1 plus 1, that is equal to 0, right? Okay, so x is equal to minus 1 is the 0 of the polynomial Gx, that is a divisor. Now do one thing, take this value minus 1 and put this minus 1 in Px, that is at the place of x put minus 1. So your Px becomes P minus 1 becomes minus 1. Like if we are, let's take this one, right? the so your px becomes 3 multiplied by minus 1 squared plus minus 1 and minus 1. Minus 1 squared means 1, and this becomes 3 plus minus 1 means minus 1 and then minus 1. So from this subtraction you get 1. Okay, so what's the point here? The point is, if you calculate the 0 of the divisor polynomial, like in this case it's minus 1, and you take that 0 and put it in px, that is a divisor, that is dividend, then the value that you will get will be equal to the remainder. That will be equal to the remainder. But the condition is your divisor should always be a linear polynomial. It should always be a linear polynomial. It cannot be a quadratic polynomial. It cannot be a cubic polynomial. It cannot be a biquadratic polynomial. Only linear polynomial, and that is what remainder theorem is all about. That's what remainder theorem is all about. Okay, so remember this thing. If your divisor is a linear polynomial, and if you find it's 0, and you put that 0 in px, that is dividend, then the value that you will get will be equal to the remainder. So either you calculate the remainder from here, like this value, by putting the 0 in px, or you go by the conventional division method, the long division method. Both these values will be equal. The condition is your divisor should be a linear polynomial. Right? Let's take one more example. Here you have minus 1 minus 4x cubed minus 3x plus 3x raised to the power of 4, and gx is equal to minus 1 plus x. First, rearrange the terms. So this is 3x raised to the power of 4, then minus 4x cubed, then minus 3x. Pay attention, you don't have x squared term, right? So pay attention to that, and minus 1. Your gx becomes x minus 1. Now let's divide. So let's copy this, or let's write like here. It's 3x raised to the power of 4 minus 4x cubed minus 3x and minus 1. From here, this is x minus 1. So pay attention to the first term of this dividend, that is 3x raised to the power of 4, and the first term of this divisor, that is x. If you divide, you will get 3x cubed. Now this 3x cubed will be the first term of this quotient, right? So 3x cubed multiplied by x will be 3x raised to the power of 4, and then this 3x cubed multiplied by this minus 1. 3x cubed minus 1 means minus 3x cubed. Now when you divide this, this is minus, this is plus, so you get x cubed, and then you have minus 3x and minus 1, right? X cubed minus 3x minus 1. Okay, now now take this is the new dividend. So this is x cubed, this is x cubed. Now x cubed and the first term of this divisor, that is x, that gives you x squared. Okay, that means, sorry, this is minus x cubed. I'm sorry, this will be minus x cubed, because minus 4x cubed plus 3x cubed means minus x cubed. So this is minus x cubed. Here you'll get minus x squared. You get minus x squared. Now the second term of this quotient is minus x squared. Okay, minus x squared multiplied by x gives you what? Minus x cubed. Okay, then minus x squared multiplied by minus 1 will give you x squared. but here you don't have the x squared term like that we have note down from here. So that's why minus x squared multiplied by minus 1 means plus x squared. So write it here, plus x squared. Okay, now the basic concept of division, the subtraction one plus this is minus, so this becomes minus x squared, and from here you get minus 3x and then minus 1. Okay, the new dividend is x minus x squared minus 3x minus 1. The first term is minus x squared, so minus x squared, the first term of divisor is x, so you get minus x. It means that the third term of the quotient will be minus x. Minus x multiplied by x is minus x squared, minus x multiplied by minus 1 will be plus x. So this is plus x. Now this becomes plus, this becomes minus because we will subtract. So minus 3x minus x means minus 4x, minus 4x minus 1. Okay, now this minus 4x minus 1 is a new dividend and x minus 1 is a divisor again. First term is minus 4x, right, minus 4x. The first term is x, so x divide, you get minus 4. It means that the fourth term of this quotient will be minus 4, right, minus 4 here. Minus 4 multiplied by x is minus 4x. Minus 4 multiplied by minus 1 is plus 4. Now when you divide this, when you subtract this, this becomes plus, this becomes minus, and you get minus 5. Now you cannot divide further, and this will be the remainder of this division. And why? Because your remainder, the degree of the remainder is always less than the degree of your divisor. Your dividend has always to be of greater degree than divisor. In this case, the degree is what actually? The degree is 0, and the degree 0 is less than the degree 1 here. That's why we cannot divide it further. That's why this is the remainder. The remainder's degree has to be less than the divisor 1, or it has to be a 0 polynomial. You cannot divide it further, right? Because now here degree is 0, here degree is 1. Okay, so this is your remainder. Now if you want to write it in the form of px, like this one, px is equal to gx multiplied by qx plus rx, as we did here, you can do that. But for to discuss the remainder theorem, the important thing is that again this is a linear polynomial. This is our linear polynomial. Okay, it's 0. This polynomial's 0 will be, this is gx is equal to x minus 1. So if gx is equal to x minus 1, if you have to find it, if you have to find out its 0, we equate it to 0. That means x minus 1 is equal to 0. That means x is equal to 1. X is equal to 1 is the 0 of this polynomial. It means that if you put 1 at the place of x in gx, you will get 0. So 1 minus 1 will be 0. So x minus x equal to 1 is the 0 of this polynomial gx. Now take this value x equal to 1, put this x equal to 1 in px, and you will get this remainder minus 5. That value will be minus 5. Let's check it. So let's remove this. Your px is, so p1 will be 3 multiplied by 1 raised to power of 4 minus 4, 1 raised to power of 3 minus 3 multiplied by 1, and this minus 1. This gives you 3 minus 4 minus 3 minus 1. So from here minus 4 minus 3 is 7. Minus 7 minus 7 minus 1 is minus 8. So this is 3 minus 8, and this gives you minus 5. This value that you get after putting the root of gx into px, you get is equal to the remainder of this division. Okay, so this value is equal to this value. So whether you take this method of long division method and then find the remainder, or you take this approach of first finding out the root 0 of the divisor and then put that 0 in the dividend polynomial, you'll get the same value, right? Same remainder. So now we finally can talk about the remainder theorem. So the remainder theorem says that let Px be any polynomial of degree greater than or equal to 1, and let A be any real number. Let A be any real number. So A is any real number. We know that to represent a real number, we take the help of capital R. This shows the set of all the real numbers, whether they are rational numbers or the irrational numbers. Be any real number if Px is divided by the linear polynomial x minus a, then the remainder is Pa, right? Then the remainder is Pa. It's saying that if your linear polynomial is of the form, is x minus a, right? So if your linear polynomial is x minus a, tell me what will be its 0. So 0 will be what? You put this equal to 0, then calculate it, x is equal to a. It means that if you put this x equal to a here in this linear polynomial, that is divisor, a minus a becomes 0. That's why this is the 0 of this divisor one. Okay, that is gx. This is our gx polynomial, the divisor one. So x equal to a is the 0 of this gx. Now then the remainder is Pa. So Pa means what? Actually you are put at the place of x in Px, you are putting Pa. Right? So the value that you will get will give you the remainder. That's what we have seen here, right? That's what we have seen here. The condition is it has to be a linear polynomial, this gx. That's what it says here. Let Px be any polynomial of a degree greater than or equal to 1. That's what we discussed here. Degree of Px is always greater than or equal to 1, and it is greater than or equal to gx to 1, and let a be any real number. If Px is divided by the linear polynomial x minus a, then the remainder is Pa. A can be any real number. Okay, now I'll show you the proof of it. Here what we saw here is not a proof. Let's see the proof. Okay, so if your Px is your polynomial, your gx dividend is gx is a divisor, and Rx, let's take Rx as the remainder polynomial and Qx as a quotient polynomial. Then from that we can write it as Px is equal to gx multiplied by Qx plus Rx. Okay, now tell me, when we are talking about the remainder theorem, in the case of remainder theorem, one condition is fixed, that gx has to be a linear polynomial. If gx is a linear polynomial, then one thing is clear, its degree will always be equal to 1, right? That is fixed. If that is fixed, then one thing is also fixed that we have seen in these two examples, that your degree of Rx is always less than the degree of the divisor. The degree of Rx, that is the degree of remainder, is always less than the degree of divisor. It means that if the degree of your divisor is 1, then the degree of the remainder polynomial or the remainder will be what? 0. It will be a 0, right? Okay, so here your Rx has to be 0 now. The degree of Rx has to be 0. It means that if the degree of a polynomial is 0, it means that we are talking about a constant polynomial. We are talking about a constant polynomial, right? The degree is 0. The degree is 0 only in the case of constant polynomials. So actually we are talking about constant polynomials. And let's say that in the case of remainder theorem, your remainder is a constant, and let's denote it by r. Let's denote it by r. Okay, so this is your r. Now, if a is a 0 of this polynomial, if we write it like this is x minus a. So px is equal to your gx is what? X minus a. That's what we have taken here. X minus a linear polynomial into qx plus rx. As we have seen here, in the case of linear polynomial, will always be a constant polynomial. Let's denote it by r. Let's say that our remainder will be a number r. Okay. Now, if you know that the 0 of this polynomial is a, then if you put here pa is equal to a minus a multiplied by qa plus r. Now a minus a is what? A minus a is 0. So your pa is equal to 0 multiplied by qa plus r. So this becomes pa is equal to 0 multiplied by qa means what? That is 0. So pa is equal to r. What does it tell us? It tells us that when you take the 0 of this polynomial x minus a, that is equal to a, and you put that in px polynomial, then the value that you get is actually equal to this remainder. That is actually equal to remainder.